All right, guys, our second lesson here, we're going to be looking at understanding the limit. Now, before you even try that bell work, I'm going to quickly just remind you that this here should not be an x. That is a mistake. That should be a 3. Okay, so it should be f of 3 equals 2. So go ahead and now pause it and give these two a try. All right, so hopefully you were able to do that. Now, this first one, I'm not going to bother writing it out because it says to say it in words. We'll just say it. So this should be the limit as x approaches 3 of f of x is 5, or we could say the limit of f of x as x approaches 3 is 5. All right, now this second one here we can talk about a little bit. So the significance of this is that if that limit is 5, but we know that f of 3 is not 5, it's 2, what this means is that there's a point of discontinuity. So if we had a graph and we're going like this, and it continues on in some way, whatever, doesn't really matter. And this hole here is at the point 3, and then this is at like 5. Then what it means is there's a hole, and then there's a little jump, and down here, there's a point where the graph exists, but it's at 2. Now the limit can still exist because it's approaching the same thing from left and right, even though the function is something different. So that's the significance there. All right, let's jump in and take a look at some examples then and start our topic. All right, so the equation of the function graph to the right here is this function f of x. The coordinates of this hole here are -3, 7, 6. Okay, and what we're going to do is we're going to compare some pre-calculus statements with some calculus limit notation. So in pre-calc, we said as x approached negative infinity, the graph of f of x approached 2, right? Our horizontal asymptote here. Okay, in calculus, we say the same thing, but instead of writing it all out in words, we write it in notation, which is the limit as x approaches negative infinity of f of x equals 2. Now, in this particular case, when it goes off to the right, it's also approaching that horizontal asymptote. So as x approaches infinity, f of x approaches 2, which would mean the same thing here for our calculus notation, except that instead of negative infinity, it's approaching infinity of f of x is also going to be equal to 2. Now, as we approach -3 from the left, so as we're approaching -3 here, and we're doing so from the left-hand side, we're going to approach 7, 6. Okay? Now, likewise, if we approach it from the right, we're also approaching 7, 6. That won't always be the case, but in this case it is because it's a hole. And so how do we write that in calculus notation? Well, we would say the limit as x approaches 3 from the left, or -3, sorry, from the left, which is why we need that negative up in the top there as well, of f of x is equal to 7, 6. Now, likewise, if we approach it from the right, the only thing that needs to change here is that we're approaching -3 from the right, and we put a plus sign up here, okay? Of f of x is also going to be 7, 6. All right, our next one's as x approaches 3 from the left, the graph of f of x, and if we go look up here, 3 is that asymptote. So from the left, it plummets down here, right, to negative infinity. And from the right, it jumps up to positive infinity. So when we're looking at this, as it approaches 3 from the left-hand side, it went to negative infinity. And as it went to 3 from the right-hand side, it went to positive infinity. So the way we write that out is the limit as x approaches 3 from the left of f of x is equal to negative infinity. And likewise, the limit as x approaches 3 from the right of f of x is going to approach infinity. Now, what does this mean? This also means that the limit as x approaches 3 from both left and right of f of x does not, well, let's put it in caps, does not exist because we get two different values, okay? So let's actually write out then what our limit existence theorem is here, okay? So how do we know that the limit exists? Well, let's write that out. So what we've got is if the function at a approaches the same value from the left and right, then the limit exists even if the function at a is different or does not exist, DNE. All right, now that's kind of like that example we just did in the bell work where the actual function was 2, but the limit was 5, okay? And we can actually have it where the limit at that at 3 doesn't exist at all. It just doesn't exist. So let's take this and do a few examples to kind of show this, all right? Now, our key for all of this is going to be that we want to see if the left side equals the right side. If it does, then the limit exists. And if it doesn't, the limit doesn't exist, okay? So the limit as x approaches 2 from the left-hand side is positive infinity. The limit as we approach it from the right-hand side here is positive infinity. F of 2 is undefined because it's a asymptote there. So does the limit exist or not? And why? Well, yes, it does, because f of x approaches infinity from the left and right. Okay, from both sides, it approaches the same thing, which in this case is not a value, it's a concept, it's infinity. All right, what about this next one here? Okay, as x approaches 2, this is where my hole is, from the left. Well, it approaches 2. And as we approach it from the right-hand side, we also get 2. But f of 2 is down here, it's actually negative 3. Does it exist? Yes, it does. For the same reason, right? Because f of x approaches the same value, which is approaches 2. Whoa, that's a weird f. From the left and right. Okay, so it doesn't matter that the function is something different. It's approaching the same, and that's what the limit is talking about. It's about what it's approaching, what it's getting close to. And our third one here, as we approach 2 from the left-hand side, we get 3. As we approach it from the right-hand side, we get negative 3. And at 2, we got to go to where it's filled in here, so it's 3. Does the limit exist? No, it does not. Why? Because f of x does not approach the same thing. Does not approach the same value. Or we could say the same y from left and right. Okay, it's approaching two different things, therefore the limit doesn't exist. All right. Now let's take a look at this with a couple of different examples on the same graph here. So first one here is that the limit as x approaches negative 3 from the left. So we're approaching negative 3 here from the left-hand side. We're going up to positive infinity as we approach that. Asymptote. Okay, our next one is as we approach negative 5. Negative 5 from both sides because it doesn't specify. So if we look at it, negative 5 here from the left, we approach 4. From the right, we approach 4. Therefore, it does exist, and it is just 4. Then we're going to look at as we approach negative 1 from both sides. So negative 1 is right here, and we can see that from the left and right, we're both approaching this value here, which is a little hard to see, but it is negative 1. So on both sides, we're approaching negative 1. Now we're going to look at approaching negative 3 from both sides. So that's this asymptote. And we can see we already know that from the left we went to positive infinity, but from the right-hand side here, we go down to negative infinity. Therefore, since it's approaching two different things, it does not exist. Why? Because the limit as x approaches negative 3 from the left of f of x does not equal the limit as x approaches negative 3 from the right of f of x. These two things are not equal, therefore it doesn't exist. All right, what about if we approach 2 from the left? Now, the thing is, almost always a one-sided limit will exist. Almost always. Okay, so let's take a look, see what it is. So if we're approaching 2 here from the left-hand side, we're approaching positive 1. What about when we approach 2 from the right-hand side? So now we're approaching 2 from this side. Well, we're getting 6. All right. Now, does the limit of f of x as x approaches 2 exist? Well, we already know it doesn't because from the left it was 1, from the right it was 6. So this does not exist for that same reason, right? Basically, 1 does not equal 6, okay? And that is just our limit as x approaches 2 from the left of f of x doesn't equal the limit as x approaches 2 from the right of f of x. All right, now these ones are a little bit different because we're approaching infinity. That means we're looking at what happens at the extreme left and the extreme right. So does the limit as x approaches negative infinity of f of x, what is it going to? As we go to the extreme left here, we're just going to get closer and closer to this asymptote of 2. And what about when we go to the extreme right? So we go to the extreme right here, this arrow means that this keeps on going, so it's going to go up to infinity. Now, these two things, as I just kind of mentioned, they're what we call end behavior. We're looking at what does this thing do as we go to the extreme left and the extreme right. All right, guys, that's going to be it. After this, you just got your practice problems, so give those a try, and we'll see you next time.